All right, good morning. As last week, we reached 6.2, and now we shall continue with the steps of counting elements of a set. Yes. Starting at page 144. Exercise 6F 1. The first one, yes.
May I go buy something real quick?
Square. PQ 72. We have P, we have Q, 7, 2, 5, and 6. So looking at this Venn diagram, the first question states P intersecting with Q. So when we look at P intersecting with Q, you have to look at the numbers that are the same as in P as in Q. So you have to look in the middle. How many people are intersecting in P as in with Q? The amount of people? 2. So let's say we're talking about who likes pizza and who likes quesillo. You have 2 people that like pizza as like quesillo. So the intersection of P and Q equals 2. B in P but not Q. But not Q. If you notice correctly, this is P. But the 2 students here belong to P as to Q. That means only 7 students only belong to P. So the answer is 7. Q but not in P. So it's vice versa. Everything or everyone that's in Q but not in P. These two persons are also in Q as in P, but I'm only looking for Q, meaning only 5 people. Neither in P nor Q. So I need to look for the amount of people which none of them are in the circle, which is easy. It's that person or those persons, which sums up to 6. E. NP. Now what is NP? NP means everyone who likes pizza, which is this circle, meaning these two get included. So the total number equals 9. F. Q. So I'm looking at everyone in Q. So I'm looking at Q, meaning 5 with 2. Total amount equals to 7. P with the union of Q. So I need to count everyone in both circles, remembering not to count the 2 twice. So it's 7 with 2 and 5. The total being 14. H and U. Now what is the U? If you notice outside, the U stands for everyone. You, everyone. So it's the 14 with the 6, meaning a total of 20. And P apostrophe, the complement of P. Now what is the complement of P? That means everyone that's not in P. So this is P, and I want everyone else that's not in P, which is these 11 people. Everyone not in P. Last one but not least, Q apostrophe. As the same thing with I. I'm looking at Q. Everyone that's not in Q, meaning 7 and the 6, a total amount of 13 people. So this was an exercise about counting elements in a specific set. Six point four talks about number theory. In the exams, you can receive examples containing number theory. In the days of the first century, the only numbers that existed was the set of whole numbers. And what is the set of whole numbers? Is starting at 1 all the way to infinity. Meaning in the early days, negative numbers did not exist. Fractions did not exist. The number 0 did not exist. So in an exam, they can ask you, give the answer. They can say, for example, X equals or is an element of W. So if your answer is 1.5, you have to round it off to 2 because your answer has to be a whole number. So they're gonna start using symbols and stop using words. Give your answer as an element of the whole number. So your answer cannot be in a fraction. The next set of numbers is when a set of mathematicians came together and they called this the natural numbers. And what are the natural numbers? The natural numbers are the whole numbers that include the number 0. Because you can imagine back, if you say I have 0 of something, they would look at you like a crazy person. 0 does not exist. So we did a lot of convincing for the number 0 to exist. So firstly, we only had the whole numbers, meaning positive numbers starting with 1. With time, the natural numbers came to existence, meaning 0 was included. So the only difference between whole numbers and natural numbers is the 0 is included. It's the only difference. You can see some exercising starting to say, give your answer as n. You will see something like this. Give your answer as n. So you know it's the numbers from 0 until infinity. Whole numbers, fractions, decimals cannot be included. Whole numbers. As time progressed, integers. Another set of numbers came to existence. Which is called integers, which many of you have seen before. And integers are whole numbers ranging from negative to positive. From negative to positive. So, ranging from the negative infinity minus 10 minus 3, 0, 1, 3 to infinity. So they can say, this especially comes forth in chapter 4. They can give you an exercise like this, and they say the answer is an element, let's say, of the set of integers. So when you have something like this, you know your answer has to be a whole number ranging from negative all the way to positive. As the time progressed, there is something called Q, and in this particular set, it's split into rational numbers and irrational numbers. What are rational numbers? Rational numbers, easily explained, are fractions. For example, a half, 3 over 7, 10 over 21, 14 over 151. Those are rational numbers. Irrational numbers could be better understood as numbers that cannot be in a fraction. It is not possible for these numbers to become in a fraction. For example, the square root of 5. 0.7319913. Pi. These numbers cannot be placed in a fraction, so they are called the irrational numbers. And last but not least, we have the real numbers. And the real number system includes everything else. Meaning, whole numbers, natural numbers, integers, and rational and irrational numbers. This symbol is the symbol they use the most. Your answer is in R, meaning it could be a fraction, it could be a negative number, it could be a square root of a number, it could be anything. So in CSEC, in the majority of time, they use R, Z, let's say N. They use N, Z, and R. They use these three most commonly to give your answer as. So if you look at the table of 6H, exercise 5, the number 7 pertains to the natural numbers, the integers, the irrational numbers, and the real numbers. You have to look at it. Let me draw it nicer. This is Q. Oh, Z. Q. And this is R. So if a number is in here, obviously it's part of all the rest. But if I have an integer, for example, -8, -8 only belongs to the integers, rational numbers, and the real numbers. It does not belong in these two. But if I have, for example, the number 5, the number 5 belongs to whole numbers, natural numbers, integers, rational, and real numbers. The deeper it's in, the more elements it belongs to. The outer it is, the less elements it belongs to. So if I have 3/7, it only belongs to the rational numbers and the real numbers. That is the way you have to look at it. In the exams, you will see stuff written like this. So give your answer, X is an element of N and is not an element of Z. So you can getting used to seeing answers written in this way. It will not say, give your answer in a decimal, but rather, give your answer in Q. And Q means it has to be in a fraction. Oops. Afterwards, you have 6.5, and all exam questions are more or less from chapter 5. So from chapter 6.1 until 6.4 is an introduction, and then 6.5 are exam questions.